Imagine a world where everything you see has an exact opposite. A twin so perfectly aligned with it that if they ever touched, they'd both vanish in a flash of pure energy. This isn't science fiction. It's the world of antimatter, one of the strangest, most powerful forces in the universe. Scientists believe that antimatter could hold the key to interstellar travel, unlimited energy, or even the secrets of how our universe began. But here's the catch. Antimatter doesn't want to stay around. The moment it meets regular matter, it's gone in a flash. So, where does it come from? And why is there so little of it in our universe? First predicted by a brilliant physicist almost a century ago, antimatter has fascinated and frustrated scientists ever since. It's been detected in cosmic rays, recreated in particle accelerators, and even trapped for just a few moments in the world's most advanced laboratories. Some say antimatter could power spaceships for journeys far beyond our galaxy. But right now, producing just a few particles of it costs millions. So, why do scientists keep chasing this elusive substance? What makes antimatter worth all this effort? Stick around, because today, we're diving into the mysteries of antimatter, how it could transform our understanding of the cosmos, and why it might just be the universe's greatest disappearing act. What is antimatter? Antimatter is the opposite of regular matter. Just like regular particles, such as protons, electrons, and neutrons, each has an antimatter counterpart. For example, the antimatter counterpart of an electron is called a positron, which carries a positive charge instead of a negative one. How does antimatter work? When antimatter meets regular matter, they instantly annihilate each other in a flash of energy. This reaction releases a large amount of energy, following Einstein's formula E equals mc squared. Even a tiny amount of antimatter could release energy comparable to a nuclear explosion, making it extremely powerful. Where do we find antimatter? Naturally, antimatter is rare and unstable. We find traces of it in cosmic rays, radioactive decay, and even thunderstorms. Scientists can also create small amounts of antimatter in particle accelerators, but it requires a lot of energy and is very difficult to store. Why is antimatter important? Antimatter might hold answers to some of the biggest mysteries in physics. The Big Bang should have created equal amounts of matter and antimatter, yet our universe is almost entirely matter. Understanding why this imbalance exists could reshape our understanding of the universe. Applications of antimatter. Today, despite the challenges, antimatter has practical uses today. In medicine, positrons are used in PET scans, helping doctors detect cancers and study brain activity. This is one of the few real-world applications of antimatter right now. The future potential of antimatter. If we could figure out how to produce and store antimatter safely, it could revolutionize technology. It's an ideal fuel for high-energy applications. Some even imagine it powering spacecraft to distant stars. But the technological hurdles are huge, making this a vision for the distant future. Antimatter pushes the boundaries of what we know about the universe. As we unlock more of its secrets, we move closer to solving fundamental mysteries of existence, and maybe one day to harnessing its incredible power.